Oops, no. So chlorine is actually having a total of the atomic number of chlorine is actually 15, I think. No, is it 16? Yeah, 17. Because we know argon is basically 18, potassium is 19, calcium is 20, which means we go backward, then chlorine is 17 atomic number, which means we need to have 17 here actually. So yeah, this is the electronic configuration. This is 5. So this is 1 is 2, 2 is 2, 2 is 6, 3 is 2, 3 is 5, 2, 4, 10, 12, 17. So there's the configuration. So when you add up one electron, you get 6, and you get in the octet state because you have a full p orbital. The p orbital is full when 6, just like this 2p, and therefore will be in the octet state, just like argon. Argon is in the same configuration, but with 6 instead of 5. We'll write it all up. But 1 is 2, 2 is 2, 2 is 6, 3 is 2, 3 is 6. So okay, this is like a quick preview of electronic configuration to write them. But today we're not going into that. If you want to learn how to do this, comment below and we'll look over it. So technically these are about ions. Now the naming conventionally for cations, all you have to do is write the name of the element and add ion as suffix. So this is sodium, and all you have to do is add the ion. So if we had a case where we had instead of potassium ion, this will be called potassium ion. You get a picture. Calcium, it will be like calcium ion. Now notice when we have ions, whether they're positive or negative, if it is just one, as the ion, they lose just one electron, then we don't need to put a 1 in front. But if it's any other number, then you must put the number, for example calcium 2. So going to the anions, when naming the anions, it's different because you write the name of the element quite alright, like chlorine, but instead of the green, now you replace it by suffix "ite". So the suffix "ite" is for anions, which means that for fluorine, which is -1, it will be fluoride. Same thing for whatever ion we're going to talk about. So let's go to transition elements, because transition elements also follow this way, but they're a little tricky. For example, ion actually has 2 oxidation states. It has 2 states. We have ion 2+ and ion 3+, and that's the main property of ions, of transition elements, which causes them to be in that section of the group. So chemistry, if I didn't know, we say it is like learning how to speak the language of chemistry, and it's based on the periodic table. For example, these anions and cations, sodium and chlorine. Sodium are metals, while chlorines are non-metals. Metals, which means they are in group 1. Now we have the non-metals, which are in group O or group 8. Group 8. So now this guy here are transition metals, and they have another way of being called transition metals. So yeah, since these are cations, you call it ion, quite right. But now, since there are 2 types of ions, chemistry has brought up a law which you use Roman numerals. Yes, we're using Roman numerals, and now you add the Roman numeral, and now you add ion, just like in cations and anions. The Roman numeral is there to give you the number of ions we're talking about, where ion and ions. Oh no, whether the ion is having 2 plus ions or the ion is 2 plus. So yeah, if you figured it out, then this will be ion Roman 3 ion. So if you notice, I put the Roman numerals in brackets, in parentheses, small parentheses. Make sure you always do that, because trust me, chemistry teachers will mark you off. Trust me on that. I have experience. So like, let's try with another transition metal, like any metal. I don't know, like, should we use copper? So I know copper is having 1 plus oxidation state and 2 plus. Therefore, if you figure it out, then copper is an O. Copper 1 ion and copper 2 ion. So most transition metals, well, all of them transition metals are basically metals, and which means they all form cations. So you won't be seeing any transition non-metal that doesn't exist. So now let's move on to acids. Acids are, well, most conventionally made up of the formation of a metal and a non-metal. A metal and a non-metal will form, what am I saying? Metal and a non-metal will form a salt. Sorry, what am I saying? Actually, to get an acid, you will need hydrogen. An acid is basically anything that gives out hydrogen. Yeah, anything that gives out hydrogen. And most conventionally, a metal is made up of a hydrogen ion linked to a non-metal. That's what gives us an acid, which means a hydroxide ion linked to a metal gives us a base. And now an acid plus a base gives us also a salt. So notice that 2 ways of getting a salt, and then metal and non-metal gives us an acid, gives us a salt, and acid and a base gives us a salt. But to get an acid, you get the hydrogen proton plus the non-metal, get an acid, and a hydroxide ion plus a metal to give a base. Remember that non-metals are actually negative and metals are actually positive. So the negative and the positive combine to give an acid which is stable, while the negative and the positive combine to give a base which is also stable. So it's all about stability. This metal is positive, this non-metal is negative, so they combine each other to form salt. And any like bond between ions, positive and negative, is called an ionic bond. An ionic bond is basically a bond formed between a metal and a non-metal, or a cation and an anion. English is so hard. Chemistrian. I'm talking chemistrian, yeah. So let's go quick to an example. For example, let's take the anions which you used, sodium and chlorine. So we have a sodium ion, usually aqueous, plus a chloride, not a chlorine ion, a chloride. So this will react on certain conditions to give us sodium chloride, which is a salt. So this is the very first one here. Metal like sodium and non-metal, they're going to give us a salt. So we know the name of this sodium ion, and this is the chloride. So this name is pretty much easy, no? For conventional reasons, or the rules of chemistry, to name this, you just take the name of this and the name of this and you concatenate it, which means this will be sodium chloride. So remember, this was sodium ion, and this one is chloride. So all you have to do is take out the ion and link these two, which gives you sodium chloride. Let's try another one. Calcium plus like a sulfate will give you calcium sulfate. So I'm just going calcium sulfate. Okay, I didn't use a metal denominator. I actually use a radical. Surface radical. We'll be coming to radicals in a second. So let's use transition metals like this plus chlorine deposit. Aqueous. Oops, that was aqueous. So if you remember this ion 2 plus ion Roman 2 in parentheses ion, and this is a chloride ion. So this gives us FeCl2, aqueous. So to name this, remember this is ion in parentheses Roman 2 ion, and this is simply chloride. Same rule goes here. You remove the ion and you just add up the two names. So this is ion Roman 2 chloride. You see, the beauty about chemistry is that you just have to follow the rules. It's all about the rules. So in our next video, we'll be talking about acids. We're talking more about acids, talking about radicals, and talking about some rules in writing these stuffs like the calcium sulfate and stuff. They actually have a whole lot of rules in writing them. So thank you for watching, and see you soon. See you in the next video.